Question 4, the volume of a sphere. Well, this time we're given the volume. Okay, so let's just draw our generic sphere with the front kind of line shown, or what's this called, the equator, and the back equator in a broken line. Okay, so let's see that we do not know R, but we can write down R is what we want. And let's write the volume with a formula: 4 pi R cubed over 3. And let's write it that we know its value. So I'll make an equation now. It's 4 pi R cubed over 3 equals, so we'll set this to the value that we know it to be. So this is very, very good algebra now. Okay, now we look at that. I'm going to write another line, but you won't need to. Okay, we will look at that and we will cancel the pi's on both sides. Okay, now we will look at the 4 and the 3, which are both factors. This is a multiplying factor and this is a dividing factor, and we will multiply up the 3 and we will divide down the 4, because the opposite to multiplying by 4 is dividing by 4, or it just simply comes down to the bottom, and we will have R cubed equals this. Okay, we'll do most of the rest on the calculator. I'm running out of space, so we will now or we can stay in the calculator and say, well, if I want the R value, I will get the cubed root of 3 by 288 over 4, and if I put that in the calculator, I'll get my answer directly, which is better. Okay, so on this calculator I have a shift with the square root, gives me the cubed root directly. I'll show you the other calculator now in a second, and I can go 3 by 288 all over 4 equals 6. Okay, 6 centimeters. On this calculator I can't, it's slightly different. I have to use the generic root. So it's not square root or not cubed root, it's the generic root, or the general root button. And so, but here's a trick. I can do two things. I want to show you if you just use it with shift, but I can do better. I can put in the order of the root that I want, and then I can shift push it. Okay, and now I'm in the same situation as this, and I can continue on and get 6. Okay, very good. One question to go, lads. Let's go for this. Question 5 in homework last night. Question 5. The surface area of a sphere is 616. Oh, brilliant. Okay, so again we've no picture, so we're going to draw a picture. We'll draw in the front of the equator and broken line the back, or you might just, you could skip the broken line at the back and say that's all I can see. Either way, this is your drawing of the 3D sphere. Obviously it's 3D if it's a sphere, but that's a nice way to remind ourselves. And we remind ourselves of the equation of the area is the same as 4 times the equation of the area of a circle. 4 pi r squared. Okay, so we can set that to the value 616. We can ignore that and use our calculator value as is policy, because the department don't do this anymore. The exam won't do this anymore. Okay, so we have 4 pi r squared. Now notice importantly it's a square because it's area, so you do not want to be putting a cube there. It's a common mistake. 4 pi r squared equals 616. Okay, so now I want to look at this and I want to show you that r squared has the variable we want. So first we're going to isolate r squared by dividing by 4 pi. So this is a multiplication factor and it will divide down. Okay, so our next line here is r squared equals 616 over 4 pi. Okay, and the next thing is, it's not r squared we want. They asked us to get r, the radius of the sphere, and later we'll get the volume of the sphere. So we need to take a square root. So r equals the square root of 616 over 4 pi. This is real honors maths now, lads. This is where it's at. This is brilliant. Okay, you can use either calculator. I'll just favor the newer one for this because at least the square root works directly in this. So you have a square root of a fraction bar. Upstairs is 616. Downstairs in our fraction is 4 pi. It should be okay to go shift pi without the multiplication symbol there. Also okay to leave it in, and we get 7. Okay, it's for all intents and purposes to a very, very high degree of accuracy, the same as 7. So we'll call that exactly 7. Okay, and of course that's centimeters. Now the next bit of the question is find the volume of the sphere. So remind ourselves of the volume equals 4 over 3 pi r cubed, and we fill in 4 over 3 pi 7 cubed with the multiplication signs where we need them. Okay, so we'll just get, now just, you know, you said, hey, you use a fraction bar all the way across sometimes, and now you're not using it all the way across. Well, it doesn't matter, okay? And you sometimes use multiplication sign and sometimes you leave it out. Well, it's always okay to put it in. Okay, so if you're ever in any doubt and not sure, just put in a multiplication sign between each factor. Now, why did I call them factors instead of terms? It's because they're being multiplied together. Terms are added together. So put in a multiplication sign between each factor and you can't go wrong. Now I want 7 cubed. Now this calculator doesn't have a cubing function, but it has a general powering function. So I'll put a 3 here. Okay, and we can look at it in terms of pi and write that down. Always a good idea. That way you don't have to spend forever looking at the question, and you can concentrate more on doing good maths. And then I can do shift equals to look at the exact value. And they said 2 decimal places, so I'll go 1436.76. Now their answer in the book might vary slightly, that doesn't matter. And that's that's volume in centimeters cubed. Okay, and I might stop writing the 2 dp because it's kind of obvious. Okay, 8 minutes video, homework done. As always, I'll see you in the next one.